Imagine standing on a vast, open plain, the kind of landscape so wide it feels like the earth itself is breathing slowly beneath your feet. The air cool but gentle, not the brutal cold your ancestors once feared. And in the distance, you see movement. Massive shapes drifting across the horizon like living mountains, herds of mammoths grazing calmly, their tusks catching the pale sunlight, as if the world has finally decided to soften after tens of thousands of years of hardship. And everywhere you look, there is life returning, not cautiously, but with confidence, with momentum, as if nature itself believes the worst is over and the future is finally safe. For generations, longer than memory can hold, the planet had been locked in ice, a frozen grip that shaped everything, from the paths animals walked to the way humans survived day by day. But now that grip was loosening, not slowly, not subtly, but dramatically, in ways that people living through it could actually see within their own. Lifetimes, glaciers that had once stood unmoving for thousands of years were pulling back, retreating northward like an army abandoning its territory. And where there had once been endless white, there was now dark soil, wet earth, rivers rushing with meltwater, carving new paths through land that had not seen sunlight for ages. And with that change came something even more powerful than warmth: opportunity. Grasslands spread like a green ocean across the exposed land, thick and rich, feeding animals in numbers almost impossible to imagine today. Mammoths traveling in herds so large they reshaped the land beneath them. Giant ground sloths moving slowly through growing forests, tearing branches with effortless strength. Bison larger than any modern species grazing alongside wild horses, and even camels. Yes, camels, native to these lands, moving across plains that would one day forget they ever existed. And behind them, always watching, always calculating, predators followed, saber-toothed cats slipping through shadows, dire wolves moving in coordinated packs, American lions ruling territories with silent authority. That IT was a world that felt alive in every direction, not just surviving, but thriving. And right in the middle of it all, humans were changing too. They were no longer just enduring the environment. They were beginning to shape it, understand it, use it in ways their ancestors never could. In North America, groups we now call the Clovis people had developed tools. They were not just sharp, but precise, engineered. Their spear points crafted with such care that they could bring down animals many times their size, not through brute force, but through knowledge, through design, through an understanding of how things moved, how things broke, how things could be controlled. Across the ocean and lands far to the east, something even more revolutionary was beginning to take shape. Small communities were starting to stay in one place, building structures, storing food, experimenting without fully realizing it, with the very first steps toward agriculture, toward a life that wasn't just about following herds, but about creating stability, creating permanence, creating the foundations of civilization itself. And all of it, every part of it, was happening because the world was warming. For over 1,000 years, everything pointed in one direction. The ice was disappearing, the climate was becoming more forgiving, ecosystems were expanding, human populations were growing. And if you were alive at that time, if you stood on that plain watching mammoths move across the horizon, you would have believed without question that the future was only going to get better, that the age of ice was behind you forever, that the world had turned a corner it would never return from. And then, without warning, the world stopped. Not slowly, not over centuries, not in a way people could gradually adapt to, but suddenly, violently, in a way that must have felt impossible to understand, as if the rules of nature themselves had been broken, because the warmth that had been building for generations didn't just pause, it reversed. And the first sign wasn't dramatic at all. It was subtle, almost easy to ignore. The winters lingered just a little longer, then a little longer again. And then one year, spring didn't come when it should have, and the year after that, it barely came at all. Something was wrong. Something was deeply, impossibly wrong. And no one living at that time could have known that they were witnessing the beginning of one of the most mysterious and terrifying climate events in Earth's history, the moment we now call the Younger Dryas. What comes next is the part no one living at that time could have prepared for. Because when the change truly begins, it doesn't feel like a normal shift in seasons. It feels like the world itself has lost its balance. Like something deep beneath the surface has snapped, and the slow, hopeful rhythm of warming that had guided life for generations suddenly stumbles, hesitates, and then collapses into something far more brutal. Like T first, it's the cold. Not the familiar cold people already knew how to survive, but a different kind, sharper, heavier, more persistent, the kind that doesn't just arrive in winter and leave in spring, but lingers, stretches, refuses to loosen its grip. And people begin to notice that the land is not recovering the way it used to, that the snow stays longer on the ground, that the rivers freeze thicker, that the brief warmth of summer feels shorter, weaker, as if it's struggling to exist at all. And then, within what might have been a single decade, maybe even less, the change accelerates beyond anything anyone could explain. Temperatures drop so fast, it would be shocking even by modern standards, in some regions falling by as much as 10 degrees Celsius. A shift so extreme that in today's world it would trigger global chaos. But back then, without technology, without warning systems, without any understanding of climate beyond direct experience, it would have felt like the Earth had simply turned hostile overnight. The glaciers that have been retreating for over 1,000 years stop, and then they begin to grow again. Imagine watching that happen within a single lifetime, seeing the edge of the ice, which had been pulling away year after year, suddenly freeze in place, and then, almost unbelievably, start pushing forward, reclaiming land that had only recently been freed, crushing new vegetation, swallowing rivers, erasing the paths animals and humans had just begun to depend on in regions like what we now call Scotland. Glaciers reappear in the highlands, forming again where they had vanished generations before, and in North America, the massive ice sheets that had been retreating toward the north reverse direction, inching southward once more, slow but unstoppable, like a tide that cannot be held back. But the cold isn't the only problem that I in. Some places, especially far from the advancing ice, something else begins to happen. Drought. Lakes that have been stable for generations start to shrink, their shorelines pulling inward, exposing cracked earth where water once stood. Rivers that have been full and predictable become erratic, weaker, unreliable, and in regions where early human communities had started experimenting with something new, something fragile. This change hits hardest because in parts of the Middle East, small groups of people have begun to take the first steps toward agriculture. They were not yet farmers in the way we think of them today, but they were close, gathering wild grains, storing food, building semi-permanent homes, slowly shifting away from a purely nomadic life. And everything about that new way of living depended on one thing: consistency. Consistent seasons, consistent rainfall, consistent growth. And suddenly, all of that disappears. The rains fail, the plants don't grow the way they used to, the wild. Cereals they depended on become scarce, unpredictable, sometimes not appearing at all, and the communities that had started to settle down are forced to make a choice, adapt, or abandon everything they've built. Some try to hold on. Some fail. Some simply vanish from the archaeological record entirely, leaving behind structures that suggest stability, suddenly frozen in time, as if life had been interrupted mid-sentence. Others scatter, returning to older ways of living, moving again, following whatever resources they can find, their brief experiment with permanence cut short by a world that has once again become uncertain. And this pattern isn't isolated. Across continents, similar stories unfold in Asia. Monsoon systems shift unpredictably. Rains move away from regions that had depended on them for thousands of years. And entire areas that once supported human populations begin to dry out. Caves that show evidence of long-term habitation are suddenly abandoned, not gradually, but abruptly, as if the people living there reached a point where staying was no longer possible. In South America, climates shift toward colder and drier conditions, ecosystems reorganizing under pressure, and even in Antarctica, far removed from human experience, the ice itself records the disturbance, showing that this is not a regional anomaly, not a localized event, but something global, something massive, something powerful enough to reshape the entire planet's climate system. And what makes it even more unsettling is the speed. Because when scientists much later study this period, analyzing ice cores and sediment layers, they find something that doesn't fit with how climate is supposed to behave. The transition into this cold period appears to happen not over centuries, but over years, maybe even faster. Some data suggest the most dramatic cooling could have occurred in less than a decade. Some interpretations push it even further, hinting that in certain regions, the shift may have been felt within just a few years, or even a single season. Imagine that point one year, the world is warming, predictable, full of promise that a few years later, it's something entirely different, colder, harsher, unstable. And then it stays that way. Not for a generation, not for a century, but for over 1,000 years. Roughly 1,200 years where the planet remains locked in these near glacial conditions. Not quite as severe as the peak of the Ice Age, but close enough to undo thousands of years of progress. Ecosystems collapse or transform, species that had thrived begin to struggle, and humans, adaptable as they are forced once again into survival mode, reshaping their lives around a world that no longer behaves the way it should. And through all of this, no one knows why. There's no warning, no visible cause in the sky. No single event people can point to and say, that's when it happened. Only the slow realization, spreading from one generation to the next, that the world they thought they understood has changed completely. But here's where the mystery deepens, because thousands of years later, when scientists begin to uncover the evidence of this sudden shift, they expect to find a clear explanation, something that fits within the known rules of climate, something that makes sense. Instead, what they find is confusion, contradictions, clues that point in different directions, because buried deep in ice, in ocean floors, in ancient lakes and layers of soil, the Earth has kept a record of what happened, but it hasn't made it easy to understand. And the more we look, the stranger the story becomes, because the planet didn't just cool, it reacted violently. And it left behind evidence that suggests something far more complex than a simple shift in temperature. Something that might involve oceans, or fire, or even something that came from the sky. Now imagine that. Thousands of years have passed since that sudden return to cold. The glaciers have once again retreated, forests have spread, civilizations have risen and fallen, and the world looks nothing like it did during that time. But the evidence of what happened is still here, locked away in places most people will never see, waiting quietly beneath layers of ice, buried under lakes, pressed into the ocean floor, like a record of a crime that no one witnessed clearly. But everyone can feel the aftermath of, and to understand what really happened, scientists had to learn how to read that record. The most powerful of those records sits in one of the harshest places on Earth, deep in the ice of Greenland. Picture it clearly, because this is not just a frozen landscape. This is an archive, a library of time, where every single year for over 100,000 years has been preserved layer by layer. Snowfall compressing into ice, trapping tiny details of the world as it existed in that exact moment, like pages stacked one on top of another, each one holding a piece of a story no human was around to write. Scientists travel to this place knowing exactly what they're looking for, but not knowing what they'll find, setting up drilling rigs in the middle of endless white, cutting down through kilometers of ice, pulling up long cylinders that look simple at first glance, but inside them is something extraordinary. Time itself, frozen and untouched. Each layer represents a year, winter, layers darker with dust, summer layers lighter with fresh snow, first. The layers are thick, easy to read, like a book with clear pages, but the deeper you go, the more the weight of the ice compresses everything, squeezing years into thin lines that require microscopes and chemical analysis to separate. But they're still there, still accurate, still telling the story of what the atmosphere was like, what the temperature was, what the world felt like year by year, going back far beyond anything humans ever recorded. And then there are the air bubbles, tiny, almost invisible pockets trapped in the ice as it formed, each one containing a sample of the atmosphere from the exact moment that snow fell, like millions of microscopic time capsules, sealed and preserved for thousands of years. When scientists extract these bubbles and analyze them, they're not guessing what the air was like in the past. They're measuring it directly. Carbon dioxide levels, methane concentrations, trace gases that exist in such small amounts they can barely be detected today. And when they look at the layers corresponding to around 12,800 years ago, they see something that shouldn't be possible. Methane levels drop sharply. Not slowly, not gradually, but rapidly, falling by about 30% in a short span of time. And that matters because methane in the atmosphere comes largely from wetlands, from areas where organic material breaks down in waterlogged environments. And if methane levels are collapsing, it means those wetlands are disappearing, drying out, or freezing. The planet isn't just getting colder, it's getting drier at the same time, that a combination that is devastating for ecosystems. But the ice reveals something even more precise than gas levels, that it reveals temperature itself. Because hidden in the chemistry of the ice is a ratio, different forms of oxygen isotopes, heavier and lighter versions of the same element. And the balance between them changes depending on how cold it was when the snow formed. It's subtle, almost invisible, but incredibly powerful. Because by measuring that ratio, scientists can reconstruct past temperatures with astonishing accuracy. And when they reach the layers marking the beginning of this mysterious cold period, the signal is unmistakable. The temperature drops sharply, not over centuries, not even over decades, but over a span so short it forces scientists to question their own data, to check and recheck their results, because everything they understand about climate says this shouldn't happen. The system is too large, too complex, too stable to shift this fast. And yet, it did. But the ice is only one piece of the puzzle, because if something truly global happened, it should leave traces everywhere. So scientists look beyond the ice into the oceans. They drill deep into the seafloor, pulling up sediment cores built over millions of years, layers of microscopic shells, dust, and organic material that settled slowly over time, creating a timeline just as detailed as the ice, but from a completely different perspective. And when they examine the layers corresponding to that same moment, 12,800 years ago, they find another sudden shift. Tiny marine organisms that thrive in warmer waters suddenly disappear, replaced by species that prefer cold conditions. The temperature of the ocean itself had dropped. And not just slightly, significantly at the same time, the chemistry of the water changes, suggesting that something disrupted the normal flow of ocean currents, something powerful enough to alter the way heat was distributed across the planet. Then there are the lakes. Ancient lakes scattered across continents, holding their own records in the form of pollen. Microscopic grains released by plants, settling at the bottom year after year, building a quiet archive of what vegetation existed at any given time. And when scientists study those layers, they see a pattern that mirrors everything else. Forests that have been expanding during the warming period suddenly retreat. Tree pollen declines, sharply cold-adapted plants return. Species that belong in harsh tundra, like environments, reappear in places they had already left behind. It's as if the world itself had been pushed backward in time. Not metaphorically, but literally, in terms of climate and ecosystems. Tree rings tell the same story. Year by year records of growth, showing how conditions change during a tree's lifetime. Wide rings indicating healthy growth suddenly become narrow, compressed, a sign of stress, of shorter growing seasons, of colder conditions that limit survival. Some trees even show damage from sudden frosts in regions where frost had been absent for centuries. And then there's something even stranger, something that doesn't fit neatly into the story, that a thin, dark layer found in multiple locations across North America and beyond, buried in the soil, dating exactly to the moment this climate shift begins. It's called the black mat, and it's unusual because it contains charcoal, evidence of widespread fires, but not just normal fires, something bigger, something more intense. That it also contains rare elements like iridium and platinum, materials that are uncommon in Earth's crust but often associated with objects from space. And within this layer, scientists have found tiny, microscopic spheres, once molten droplets that cooled rapidly, and even nanodiamonds, structures that typically form under extreme pressure and temperature, conditions you don't usually get from ordinary environmental changes. Now, not everyone agrees on what this means. Some scientists argue these features could come from natural processes, wildfires, volcanic activity, normal geological events. Others see something more extraordinary, something that doesn't quite belong to Earth's usual patterns. But what everyone agrees on is this. The layer exists that IT appears at the exact boundary where the world suddenly changed. And it shows signs of heat, of disruption, of something violent happening at a global scale. So now, the picture becomes clearer and more confusing at the same time. Because all the evidence, from ice, from oceans, from lakes, from trees, from the land itself, points to the same conclusion. Something happened 12,800 years ago. Something sudden, something powerful, something capable of changing the entire planet's climate in what might have been the span of a single human lifetime. But the question remains, what could possibly be strong enough to do that? What force could override the natural warming of the Earth, stop it completely, and then reverse it? Was it something from within the planet? Something in the oceans? Or something far more unexpected, something that came from above? Now imagine North America at the end of the last ice age, not as the land we know today, but as something far more extreme, a continent still dominated by ice, where an enormous frozen mass, miles thick in places, stretches across the northern half of the land like a wall, cold, heavy, and slowly retreating as the world warms. And along its southern edge, where the melting is strongest, water begins to gather at first. It's just runoff, seasonal meltwater flowing into valleys, pooling in lowlands, feeding rivers that grow larger year after year. But over time, as the ice continues to melt, that water has nowhere stable to go. And so it builds and builds and builds until what forms is something so vast it almost defies the word lake. This is what scientists call Lake Agassiz. But calling it a lake doesn't really capture what it was. This was an inland sea that a massive body of freshwater stretching across what is now Canada and parts of the northern United States, covering an area larger than all the Great Lakes combined, possibly rivaling the size of entire seas, a cold, silent reservoir held in place not by solid ground, but by something far more fragile, ice, because the only thing keeping all that water contained was the very ice sheet that was melting to create it, a natural dam, temporary, unstable, and under constant pressure. Every summer, more meltwater poured in. Every year, the level rose, the weight increased, and somewhere within that frozen barrier, cracks began to form. Channels melted through the ice, weak points developed, and all the while, the pressure behind it kept growing, like a force waiting for the moment it could finally break free. Now imagine the moment that happens. Not a slow leak, not a controlled release, but a failure. Sudden, catastrophic. The kind of event that, if you were there to witness it, would be beyond comprehension. Because when that natural dam gives way, what follows isn't just water moving. It's an inland ocean being unleashed. Trillions of tons of freshwater surge forward, carving through whatever stands in its path, rushing across the land, tearing through valleys, overwhelming rivers, and eventually pouring toward the ocean in a flood so massive it would reshape the geography of entire regions. And here's where this becomes more than just a dramatic event. Because where that water goes matters. That IT doesn't just disappear. IT enters the North Atlantic. And the North Atlantic is not just another ocean. IT is one of the key engines of Earth's climate. To understand why, you have to think of the ocean not as still water, but as a moving system, a giant conveyor belt that circulates heat around the planet. Warm, salty water flows north from the tropics. As it reaches colder regions, it cools, becomes denser, and sinks deep into the ocean, pulling more warm water behind it, creating a continuous loop that helps regulate global temperatures. This system is incredibly important, that it's one of the reasons parts of Europe are much warmer than they should be based on their latitude, that IT helps distribute heat, stabilize climate, maintain balance. But it has a weakness. Because for that system to work, the water needs to be both cold and salty. Salt makes water heavier. Water sinks. and that sinking is what drives the entire circulation. Now imagine what happens when you suddenly dump an enormous volume of fresh water into that system. Fresh water is lighter. It doesn't sink as easily as instead of cooling and dropping. The surface layer becomes diluted, less dense, more resistant to sinking. And if enough fresh water enters the system fast enough, the entire circulation can weaken or even stop. And if that happens, the consequences are immediate because the flow of warm water from the tropics slows down. Less heat reaches the northern regions. Temperatures drop. Sea ice expands. Snow lasts longer. And the more snow and ice there is, the more sunlight gets reflected back into space, reinforcing the cooling even further. It becomes a feedback loop, a system that feeds on itself. And suddenly, what started as a flood in North America turns into a global climate shift. This is the core idea of what scientists call the meltwater pulse hypothesis, that the sudden release of fresh water from massive glacial lakes like Lake Agassiz disrupted the ocean circulation system, effectively shutting down one of the planet's main heat distribution mechanisms and triggering the rapid cooling we now recognize as the Younger Dryas. And when scientists test this idea using climate models, something remarkable happens that IT works. When they simulate large pulses of fresh water entering the North Atlantic, the models show significant cooling in the exact regions most affected. During the Younger Dryas, the patterns line up, the timing can match, the physics makes sense, and there's physical evidence too. Ancient shorelines marking the changing levels of these massive lakes, sediment deposits showing signs of enormous floods, ocean cores indicating sudden changes in salinity and temperature, all of it pointing toward the same possibility, that water, in unimaginable quantities, may have been enough to push the planet into a deep freeze. But like everything in this story, it's not that simple. Because when scientists look closer, they start to notice complications, uncertainties, details that don't quite fit perfectly. For one, there's the question of direction. Where exactly did all that water go? Early theories suggested a direct route into the North Atlantic, a powerful, concentrated surge hitting the very heart of the ocean circulation system. But later research hints at something different. That much of the water may have flowed northward instead, into the Arctic Ocean, spreading more slowly, more diffusely, before eventually reaching the Atlantic. And if that's true, then the impact on ocean circulation might not have been as immediate or as strong as the original theory suggests. Then there's the question of timing. For this explanation to fully work, the release of fresh water needs to line up almost perfectly with the onset of the cooling. Not centuries apart, not loosely connected, but nearly simultaneous. And while some evidence supports that alignment, other data suggest the largest flood events may have occurred slightly earlier or over longer periods, not as one single dramatic burst, but as multiple pulses spread over time. And then there's the question of scale. How much water is actually needed to disrupt the system? Some models suggest it would take an enormous, almost unimaginable volume. Others indicate that smaller, sustained inputs could be enough. And the geological record shows that multiple meltwater events occurred during this period, not just one. Was it a single catastrophic flood, or a series of events building toward a tipping point, or something else entirely? This is why, even though the meltwater hypothesis is one of the strongest explanations we have, it doesn't solve everything. It explains the cooling. It explains the mechanism. But it doesn't explain every detail. It doesn't fully account for some of the strange evidence we saw earlier. The black layer in the soil, the signs of intense heat, the unusual materials that seem to appear at the exact same moment the climate shifts, which raises a new possibility, a more controversial one. Because what if the flood wasn't the only trigger? What if something else happened at the same time? Something that didn't come from the earth at all. Something that came from the sky. Something that didn't just release water, but fire. Now, imagine looking up at the sky 12,800 years ago, not knowing anything about comets or orbital paths or cosmic debris. Just seeing the night as it has always been, stars, fixed in their patterns, predictable, distant, eternal. And then something appears that doesn't belong, something moving, something growing brighter, not like a star, not like anything you've ever seen before. And at first it might seem beautiful, even mesmerizing, but then it doesn't fade. It gets closer. Because one of the most controversial ideas about what triggered the Younger Dryas doesn't begin on Earth at all. It begins in space. According to this theory, sometime around the exact moment the climate suddenly shifted. Earth may have passed through the path of a fragmented comet. Not a single solid object like the one that ended the age of dinosaurs, but a swarm of debris, pieces broken apart long before, traveling together silently through the solar system, invisible until the moment they intersect with our planet. And when that happens, it doesn't produce one impact. It produces many. Some of those fragments would slam directly into the surface. Others would explode in the atmosphere, releasing enormous amounts of energy in an instant, like the Tunguska event in Siberia, but on a much larger scale, possibly happening multiple times across a wide region. Now picture that. Not one explosion, but a series of them, across an ice-covered continent, over forests, over open plains, each blast hotter than anything seen in natural fires, hot enough to melt rock, vaporize ice, ignite entire landscapes in seconds, sending shockwaves through the air, flattening everything in their path, and throwing debris high into the atmosphere. The sky itself would change. Smoke and ash rising into the upper layers of the atmosphere, spreading across continents, blocking sunlight, dimming the world below, creating what scientists call an impact winter, a period where temperatures drop not because of long-term climate trends, but because sunlight itself is being filtered, reduced, weakened. And on the ground, the effects would be immediate and devastating. Forests burning on a massive scale, grasslands igniting, animals caught in the open with nowhere to go, ice sheets, already unstable from warming, suddenly exposed to extreme heat, melting rapidly in localized regions, releasing vast amounts of fresh water in a very short time. And that's where this theory connects back to everything we've already seen. Because if something like this happened, it wouldn't just cause fires. It wouldn't just darken the sky. It would also accelerate the release of meltwater, potentially triggering the same kind of ocean disruption described in the meltwater hypothesis, but faster, more violently, more suddenly. In this version of events, the Younger Dryas isn't caused by just one factor. It's a chain reaction. Cosmic impacts, followed by massive fires, followed by rapid ice melt, followed by a flood of fresh water into the oceans, followed by the collapse of ocean circulation, and then the cold. A sudden, global shift driven by multiple forces hitting the system all at once. Now, if this sounds dramatic, even extreme, that's because it is. And for a long time, many scientists were skeptical of this idea because extraordinary claims require extraordinary evidence. But then they started looking closer at that strange layer we talked about earlier, the black mat. Because if something like a cosmic event really happened, it should leave behind traces, not obvious craters everywhere, but subtle, specific signatures. And in that layer, researchers began to find things that didn't fit easily into normal explanations: tiny, microscopic diamonds, nanodiamonds, structures that typically form under intense pressure and heat, like those created during impacts, small, spherical particles of metal and glass, microspherules, formed when material is melted and then rapidly cooled, exactly what you'd expect from explosive, high-temperature events, pieces of what appears to be melted glass, formed at temperatures higher than most natural fires can produce, and elevated levels of elements like iridium and platinum, materials that are rare on Earth's surface, but more common in objects from space, not in huge amounts. Not enough to immediately prove a massive impact like the one that killed the dinosaurs, but enough to raise questions, enough to suggest that something unusual may have happened. And here's where the story becomes even more complicated, because some researchers find these signals clearly. They analyze samples from different sites and see the same patterns, evidence of heat, of rare elements, of something out of the ordinary happening right at the moment the Younger Dryas begins. But other researchers look at similar samples and don't find the same thing, or they interpret the data differently. They argue that some of these materials could come from natural wildfires, from volcanic activity, from normal geological processes that don't require anything from space. They question the methods, the measurements, the conclusions, and so the debate continues. Not about whether the Younger Dryas happened, that part is undeniable, but about what caused it. Because this hypothesis sits right on the edge between possibility and uncertainty. There is evidence, but it's not universally accepted. There are signals, but they are not perfectly consistent. And then, just when the discussion seems to settle into uncertainty, something new appears, buried deep beneath the ice of Greenland. Scientists discover a massive circular depression, a crater, over 30 kilometers wide, hidden under more than a kilometer of ice at a T. First, it seems like the missing piece, a possible impact site in the right region. Maybe even the right size, something that could connect directly to this theory. For a moment, it looks like the mystery might finally be solved, but then comes the most important question: when did it form? Because if it formed around 12,800 years ago, it could be exactly what researchers have been looking for. But if it's older, then it has nothing to do with the Younger Dryas at all. And when scientists try to date it, the results are uncertain. Some estimates suggest it could be relatively recent. Others push it back hundreds of thousands or even millions of years. And if those older dates are correct, then the crater is just a coincidence, a dramatic one, but unrelated. Once again, the story refuses to give a clear answer. And that's what makes this theory so fascinating, because it doesn't fully prove itself, but it doesn't disappear either. It lingers, supported by some evidence, challenged by other evidence, always just on the edge of confirmation. And outside of science, the idea carries an even deeper weight, because when you think about it, a sudden rain of fire from the sky, followed by floods, followed by darkness, followed by a return to cold, it starts to sound familiar, not from data, but from stories, ancient stories, because across the world, in cultures separated by oceans and time, there are myths of great floods, of fire falling from the heavens, of a previous age destroyed by forces beyond human control. Now, those stories are not proof. They change over time. They mix with imagination, symbolism, memory, but still it's hard not to notice the pattern, a real event, a sudden shift, and echoes of something catastrophic preserved in some form in human memory. But whether because it was water or fire or something else entirely, what matters most is what came after. Because the Younger Dryas didn't just change the climate, it changed life on a massive scale. Ecosystems collapsed, species vanished, and a world that had once been full of giants began to fall silent. Now imagine stepping back into that world again, but this time not at its peak, not when everything was thriving and expanding, but at the moment when it begins to break. It first, it doesn't feel like collapse. It feels like tension, like something is off. The winds feel sharper across the plains, colder than they should be, carrying a dryness that wasn't there before, and the grasslands, the vast, endless grasslands that once fed entire horizons of life, begin to thin, not everywhere at once, but in patches subtle at first, easy to ignore, until those patches start connecting, spreading, turning once rich land into something harsher, something less forgiving. And the animals feel it before anything else, because for them, there is no theory, no explanation, only change. The herds that once moved with confidence now move with urgency. Mammoths that used to roam in massive numbers begin to travel farther to find food, their routes shifting, their migrations becoming longer, more uncertain, and where once there was abundance, there are now gaps, places where the grass doesn't grow the same way, where the ground is harder, where snow lingers too long into what should be the warmer months. The giant ground sloths, slow but powerful, begin to struggle as forests change, as the plants they depend on become less reliable, less predictable. Bison, horses, camels, all of them start to feel the pressure, not as a single catastrophic moment, but as a slow tightening, a gradual loss of the stability that had allowed them to thrive. And then there are the predators, because when prey begins to decline, predators feel it immediately. Saber-toothed cats, once masters of their environment, find fewer. Opportunities. Dire wolves, dependent on the strength of the pack and the abundance of large animals, are forced to range farther, to take greater risks, to compete more aggressively. The balance that once existed begins to fracture. And when balance breaks in an ecosystem like this, it doesn't break quietly. IT cascades. Point one species declines, another follows. Food chains unravel. Relationships that took thousands of years to stabilize begin to collapse in the span of generations. And through all of this, humans are still there, watching, adapting, surviving, but also contributing. Because unlike the other animals, humans don't just respond to change, they act within it. They hunt, they innovate, they shift their strategies. And in a world where resources are becoming less predictable, that pressure increases. The Clovis hunters with their precision tools had once thrived in a land of abundance, where large animals were everywhere, where the challenge was skill, not scarcity. But now, the rules are different. The animals they depend on are harder to find. Their movements are less predictable. The numbers are no longer what they used to be, and so hunting becomes more intense, more focused, more necessary, not just for success, but for survival. And over time, something begins to happen that no one in that world could have fully understood. The giants begin to disappear. Not all at once, not in a single dramatic event, but steadily, relentlessly. Across North America, entire species vanish. Mammoths, mastodons, giant ground sloths, American lions, the short-faced bears, saber-toothed cats, native horses, camels, massive beavers, armored creatures like glyptodons, gone. Not reduced, not relocated, gone. Entire branches of life erased from the world. And it's not just one region. South America loses many of its giants as well. In Eurasia, some species survive, but others disappear. Woolly rhinoceroses, certain large deer, ancient elephant species, all fading out within a relatively short window of time. And what makes this even more haunting is how uneven it is. Because in Africa, many large animals survive. Elephants, lions, rhinos, species that elsewhere vanish, remain. Which raises a question that has never been fully answered. Why here and not there? Why did some regions lose so much, while others held on? Because when scientists look at this pattern, they see something complex, something that doesn't point to a single cause. Climate alone could explain part of it. The sudden cold, the shifting environments, the loss of stable ecosystems. But climate doesn't explain everything, because many of these species had already survived extreme conditions before. They had lived through the worst of the Ice Age. They had adapted to cold, to scarcity, to change. Oh, why didn't they survive this? And that's where humans come back into the picture. Because the timing overlaps, the spread of human populations into new regions, the development of more effective hunting tools, the increasing pressure on large animals that reproduce slowly and require vast amounts of resources. Individually, none of these factors might be enough to cause extinction. But together, they create something different, a perfect storm, a world where climate is changing rapidly, ecosystems are destabilizing, and on top of that, a highly adaptable predator, humans, is applying additional pressure. And for species already struggling to adjust, it becomes too much, too fast, too overwhelming. And so, over the course of the Younger Dryas, and the period just after it, the world loses something it had held for millions of years, its giants. And with them, it loses an entire kind of landscape, because those animals didn't just live in the environment. They shaped it. Mammoths knocked down trees, maintaining open grasslands. Large herbivores control vegetation, influencing what could grow and where. Predators kept populations balanced. When they disappear, the land changes, forests expand differently, grasslands shrink or transform. Entire system reorganizes, and humans are left in a world that is quieter, less massive, less dominated by creatures that once defined entire ecosystems, a world that feels different. But here's the most important part. Humans don't disappear. They adapt. Again, and this time, their adaptation leads somewhere new. Because in the aftermath of this long, cold period, as the climate begins to shift once more, as warmth slowly returns, as stability begins to re-emerge, humans take a step that will change. Everything does a step that might never have happened the same way if the Younger Dryas had never occurred. Because sometimes it's not the world at its best that forces change, it's the world at its most difficult. Now, imagine surviving all of that. Not just the cold, not just the hunger, not just the slow disappearance of the animals your entire way of life depended on, but generations of instability, of never knowing if the next season will bring food or failure, of watching the land change again and again until nothing feels permanent anymore. Because for humans, the Younger Dryas wasn't just a climate event, that it was pressure. Constant, unrelenting pressure. And pressure does something very specific to intelligent species. It forces decisions. Before this period, life had been moving in a certain direction that in some regions, especially in the Near East, people were beginning to settle, to experiment with staying in one place, gathering wild grains, storing food, building structures that suggested something new was forming, something close to what we would eventually call civilization. But that path required stability, that it required predictable seasons, reliable water, consistent growth cycles, and the Younger Dryas shattered that. Stability. The cold returned. The rains shifted. The plants they depended on became unreliable. And suddenly, the early steps toward a settled life no longer worked the way they were supposed to for a time. Many groups reversed course. They moved again. They spread out. They adapted in the only way they knew how, by staying flexible, by not depending too heavily on any single resource. But here's where things begin to change in a deeper way. Because living through that kind of instability doesn't just affect what you do in the moment. It changes how you think about survival. IT teaches a lesson, a hard one, that nature cannot be trusted to remain consistent, that abundance can disappear, that waiting for the world to provide is not always enough, and over generations, that lesson begins to shape behavior. Because when the climate finally begins to warm again, around 11,600 years ago, something remarkable happens. The Younger Dryas ends. And just like its beginning, the end is abrupt. Temperatures rise. Quickly, glaciers retreat once more. Forests begin to expand. Rainfall patterns stabilize. The world shifts back toward warmth. But this time, humans are different. They've lived through collapse. They've seen what happens when systems fail. And instead of simply returning to the old ways, in some regions, they begin to push further than before. They begin to control their environment. Not completely, not instantly, but deliberately in the same regions where early experiments had once faltered. People start to cultivate plants more intentionally, not just gathering wild grains, but encouraging their growth, selecting certain seeds, returning to the same areas, building more permanent settlements again, but this time with more knowledge, more experience, more understanding of risk. This is where agriculture truly begins to take hold. Not as a sudden invention, but as a response, that a solution shaped by hardship. Because when you've lived through a world where food can vanish, the idea of controlling your own supply becomes more than innovation. It becomes necessity. And from that necessity, everything else begins to follow. Permanent settlements grow larger. Storage becomes more important. Social structures begin to shift. People organize differently when they're tied to land, when they depend on crops, when survival is no longer about movement, but about management. And over time, those changes compound. Villages become towns. Towns become cities. Complex societies emerge. And eventually, civilizations. All built on a foundation that may have been shaped, at least in part, by one of the most extreme climate events in human history. And that's what makes the Younger Dryas so important. Because it's not just a mystery about the past, it's a turning point, a moment where the trajectory of life on Earth, especially human life, may have been altered by forces no one at the time could understand, but a sudden return to cold that forced adaptation, forced innovation, forced a species to rethink how it survives. And yet, even after everything we've uncovered, after all the ice cores, the sediment layers, the pollen records, the chemical signatures, the central question remains unanswered. What caused it? Was it water, released in unimaginable floods? disrupting the oceans and shutting down the planet's heat engine? Was it fire from the sky, a cosmic event that triggered chaos across continents? Was it a combination of factors, multiple systems interacting in ways we still don't fully understand? Or is there something missing entirely, something we haven't discovered yet? Because the truth is the Younger Dryas doesn't fit neatly into a single explanation. IT sits at the edge of our understanding, but a reminder that even with modern science, even with all our technology, there are still events in Earth's history that we cannot fully explain, events that happened fast, changed everything, and then ended just as suddenly, leaving behind only traces and questions. And maybe that's the most important part of this story, because it shows us something unsettling, that the planet we live on is capable of changing far more quickly than we like to believe, that systems we think are stable can shift, that the past is not just distant history. It's a warning to demonstration of what can happen when the balance is disturbed. And somewhere, locked in ice, buried in the ocean floor, hidden in layers of soil and stone, the full answer still exists, waiting to be understood, waiting for us to finally piece it together. Until then, the Younger Dryas remains what it has always been, one of the greatest unsolved mysteries in human history, at a moment when the world was moving towards something brighter, and suddenly fell back into the cold. But the story doesn't really end when the ice retreats again, because if you step back and look at everything that just happened, not as separate events, not as disconnected mysteries, but as one continuous chain, you start to see something far more unsettling than just an ancient climate anomaly. You start to see a system that can change suddenly, a system that can flip. Because for thousands of years before the Younger Dryas, the planet was warming in a way that made sense, driven by natural cycles, by shifts in Earth's orbit, by feedback loops that reinforced each other. And everything about that process suggested stability, momentum, predictability. And then something interrupted it. Not gradually, not gently, but fast enough that even now, with all our science, it feels uncomfortable to fully accept how quickly it happened. And that's the part that matters most. Because when scientists study the Younger Dryas today, they're not just trying to solve a mystery about the past. They're trying to understand a possibility for the future. Because the same systems that existed back then still exist now. The oceans still circulate heat across the planet. The ice sheets still store enormous amounts of fresh water. The atmosphere still responds to changes in gases, temperature, and sunlight. The difference is, today we are part of that system in a way we weren't back then. And when researchers look at the ocean circulation, the same system that may have been disrupted by meltwater thousands of years ago, they see something that catches their attention. They see signs that it can weaken, that it can slow down under certain conditions, that it is not as unbreakable as it once seemed. And if that system were to weaken significantly again, the consequences would not be subtle, because just like before, it would affect how heat moves across the planet. IT would shift weather patterns, change rainfall, alter growing seasons. Not necessarily triggering another ice age overnight, but enough to disrupt the stability that modern civilization depends on. And that's the key difference. Back then, humans adapted because they had to. They moved. They changed their strategies. They survived in smaller numbers, with fewer dependencies. But today, everything is connected. Food systems, cities, infrastructure, global trade. We rely on consistency, on predictability, on the idea that the climate will behave within certain limits. And the Younger Dryas challenges that assumption, because it shows that under the right conditions, those limits can be crossed, that changes don't always happen slowly, that tipping points exist. And when they are reached, the system doesn't respond gradually, that IT responds all at once. Now, this doesn't mean the same event will happen again. The conditions today are different. The causes may not align, but the lesson remains that Earth's climate has thresholds, that it has hidden sensitivities, and that when those sensitivities are triggered, the response can be faster and more extreme than expected. And there's something else, something quieter, but just as important. Because if you go back to the beginning of this story, to that open grassland, to the mammoths, to the sense that the world was improving, stabilizing, becoming more predictable. You realize something. The people living then had no idea what was coming to no warning, no models, no data. They experienced the change as it happened, reacting in real time, adapting without understanding the cause. And in a way, that makes their story even more powerful, because despite everything, the cold, the drought, the loss, the collapse of ecosystems, they didn't disappear. They endured, they adapted, they changed the way they lived. And in doing so, they set the stage for everything that came after: agriculture, settlements, civilization, all of it emerging from a period of instability that forced humanity to rethink its place in the world. And that might be the final piece of this story. Not just the mystery of what caused the Younger Dryas, but the impact it had. Because sometimes the most important part of an event isn't the trigger. It's the transformation that follows, the way it reshapes behavior, forces innovation, pushes a species to evolve, not biologically, but culturally, technologically, socially. And in that sense, the Younger Dryas may not just be a story about sudden cold IT, may be a story about pressure creating progress, about a world becoming unstable, and humanity responding by becoming something new. But even now, after all the research, after decades of study, after countless, scientists trying to piece together the clues, the full answer still isn't complete. Was it water? Was it fire? Was it both? Or was it something else entirely, something subtle, something we haven't fully understood yet? The evidence is still there that in the oceans, that in the soil, waiting, and maybe one day we'll finally connect all the pieces. Maybe we'll find the exact trigger, the precise sequence, the moment everything changed, or maybe this will remain one of those rare mysteries that never fully resolved, a reminder that even in a world we study so closely, there are still moments in its history that remain just out of reach. And as you sit here now, thousands of years removed from that event, in a world shaped by everything that came after it, it's worth remembering this. The Earth has changed suddenly before it. IT has shifted faster than expected. IT has rewritten the rules in the span of a lifetime. And if it could happen once, it means it can happen again. Not in the same way, not for the same reasons, but the possibility is always there, hidden beneath the surface, waiting, just like it was 800 years ago. And yet, the story of the Younger Dryas doesn't just end in ice and shifting oceans. Because when the ice retreated and the world began to warm again, the stage was being set for something entirely different. A story of human ingenuity, expansion, and the rise of civilizations. The abrupt cold had forced humans to adapt, survive, and innovate in ways they never had before, and those adaptations created ripples that stretched across millennia. Think about it. Small bands of hunter-gatherers, pushed by the cold into new territories, had to learn how to manage scarce resources. They began to store food. They learned which plants could survive in harsher climates, which animals could be domesticated. They developed new tools, new strategies, new social systems. In short, the pressures of sudden climate change accelerated the evolution of human culture itself. And these changes didn't happen in isolation. The groups that learned to farm, to build permanent shelters, to control water, and to trade with neighboring tribes laid the groundwork for the first great settlements. Jericho, Cattle Hoke, and other early cities didn't just appear by chance. They were the outcome of millennia of adaptation, resilience, and trial and error sparked in part by the cataclysmic shocks of the Younger Dryas. But here's where it gets fascinating. If you trace the trajectory from the Ice Age survivors to the rise of early empires, you start to notice patterns repeating themselves across time. Civilizations that mastered resource management, that adapted to environmental shocks, that innovated in technology and organization, they thrived. Those that couldn't faded into history. And the very tools that early humans developed under climate stress, agriculture, animal domestication, irrigation, long-distance trade, became the building blocks for monumental empires thousands of years later. Fast forward several thousand years, humans had transitioned from scattered villages to sprawling city-states and empires. The lessons from survival against climate extremes, though largely unconscious, had shaped how societies approached risk, resource distribution, and governance. And when you look closely, you can see echoes of the past in the great empires of history: Egypt, Mesopotamia, Persia, Rome. Every empire carried a trace of that adaptability forged in Ice Age hardship. Take the Persian Empire, for instance. Its very success depended on sophisticated management of water, crops, and trade across vast and often unpredictable landscapes. And the Romans? Their ability to control massive territories, to move armies and resources efficiently, to adapt to different environments. All of it rests on the human capacity to respond to change, a capacity tested and honed in the crucible of climate events like the Younger Dryas. And the thread continues even further. Because as empires rose and fell, the planet itself continued to shift. Oceans, rivers, deserts, and forests shaping the fate of civilizations in ways often invisible to those who lived through them. Wars were fought, borders redrawn, cities built and abandoned. But underlying it all was the same lesson the Ice Age humans learned long ago. Survival depends on understanding and responding to change. In other words, the Younger Dryas wasn't just an ancient cold snap. It was a pivot point, a moment that nudged humanity toward innovation, agriculture, settlement, and eventually empire. It's a story about how environmental shocks ripple across generations, shaping not just the lives of the people who experience them directly, but the very trajectory of civilization itself. And when you start connecting the dots from Ice Age humans to the first empires, a new question emerges. What happens when humanity itself becomes the force capable of changing the environment, intentionally or unintentionally? When we don't just respond to shocks, but create them. That's where the story starts to merge with something entirely different. Something that moves beyond the distant past into a history of conquest, empire, and human ambition. Because just as the Younger Dryas forced adaptation and innovation, later periods in history would force the same, but on a scale exponentially larger. The rise of empires wasn't just about kings, armies, or architecture. It was about the environment, the systems, the hidden pressures that guided human decisions. And if you look closely, there's a bridge between the story of a sudden ice age and the story of empires like Persia, Rome, and beyond, a continuity of survival, adaptation, and the relentless human drive to not only endure, but to dominate the world around us. And this is where our journey starts to shift, from ice and survival to politics, war, and empire building. The resilience and ingenuity that allowed humans to endure the Younger Dryas would now manifest in armies, trade networks, diplomacy, and conquest. The story of the planet and the story of humanity are inseparable, and history is about to show just how intertwined they really are. As the ice finally receded and the Younger Dryas faded into memory, the world was transformed. The frozen landscapes thawed, rivers swelled, and fertile valleys emerged where once there was only tundra. For humans, it was both an opportunity and a challenge. Those who had survived the cold, who had learned the hard lessons of scarcity, mobility, and adaptation, now faced a new problem: how to manage abundance. The same ingenuity that had kept small bands of hunter-gatherers alive in the icy grip of catastrophe became the foundation for agriculture, settlement, and eventually empire. Imagine the first farmers in Mesopotamia planting wheat and barley along the banks of the Tigris and Euphrates. They were doing more than feeding themselves. They were creating the first networks of surplus, storage, and trade. Villages became towns, towns became cities, and with cities came governance, law, and organization. The climate-driven survival strategies of the past, food preservation, cooperation, resource management, suddenly scaled to entire societies. And as these societies grew, so did their ambition. One of the most striking examples of this is the rise of the Persian Empire. By the 6th century BCE, Persia had grown into a sprawling empire stretching from the deserts of Arabia to the mountains of Central Asia. What made Persia extraordinary wasn't just its military strength. It was its ability to manage resources across vast and diverse environments. Canals, roads, and administrative networks allowed them to move armies, collect taxes, and ensure trade flourished. But underneath these innovations was a deeper truth. The Persians inherited the lessons of survival. Just as their distant ancestors had learned to adapt to climate shocks, Persia adapted to the logistical and environmental challenges of ruling a massive empire. Meanwhile, across the Mediterranean, another civilization was learning similar lessons, though in a different way. Rome, which started as a small city on the Tiber, would rise to dominate the known world not simply through brute force, but through strategic adaptation. The Romans mastered roads, aqueducts, logistics, and governance. They learned to manipulate the environment to their advantage, flooding fields, draining marshes, engineering ports. Their resilience and ingenuity echo the same survival instincts that had once kept humans alive during the Ice Age, now scaled to armies, cities, and empires. And yet, there was a profound irony. The very strategies that allowed humans to survive, control over water, agriculture, and land, were now being turned into tools of power and domination. Climate was still an invisible player. Droughts, floods, and soil exhaustion could topple kingdoms just as surely as invading armies. For every empire that flourished, another fell, often because the environment demanded more adaptation than its rulers could muster. The Ice Age lessons were still relevant. They were just playing out on a far larger, far more dramatic stage. But the connection between the past and the present goes deeper. When you trace the lineage from Ice Age survival to imperial strategy, a pattern emerges. Humans always thrive by learning, innovating, and organizing in response to stress. Whether it's a sudden drop in temperature or the logistical nightmare of governing millions of people, adaptation is key. And it's here that history begins to feel less like a story of kings and battles, and more like a story of humanity itself, the thread that links survival, ingenuity, and ambition across millennia. The story doesn't stop with Persia or Rome. As centuries pass, these early empires lay the groundwork for future civilizations. Arab caliphates, Chinese dynasties, and European powers, each shaped by the interplay between humans and their environment. The echoes of the Younger Dryas, the first farming villages, and early urban networks resonate even in the grandest palaces and mightiest armies. Every conquest, every innovation, every collapse carries the imprint of those ancient struggles to survive, adapt, and flourish. And here's the most fascinating part. By studying these patterns, we begin to see history not as disconnected events, but as a continuous story, a story where climate, environment, and human ingenuity are inseparable. The Ice Age humans, the farmers of Mesopotamia, the administrators of Persia, the generals of Rome, all are chapters in the same narrative. And that narrative doesn't just explain the past. It foreshadows the challenges humanity faces today, how we adapt to environmental change, manage resources, and navigate the complex systems we've created as we move forward in our story. The next chapter isn't just about empires or wars. It's about the way humans continue to confront change, whether natural, social, or technological, and how those confrontations shape civilizations, culture, and destiny. From ice to empire, from survival to ambition, the journey is a single continuum. And it's far from over as the world warmed and human societies flourished. Empires began to assert themselves not merely through survival, but through vision, strategy, and power. Persia, under the Achaemenid dynasty, became the archetype of a well-organized, multi-ethnic empire. Cyrus the Great didn't just conquer lands. He built bridges, literally and metaphorically, uniting diverse peoples under a single administration. Provinces paid tribute, yet retained local customs, a system that was revolutionary for its time. Persian roads and courier systems allowed messages to travel hundreds of miles in days, connecting the vast territories from the icy mountains of Armenia to the deserts of Egypt. Every innovation, from irrigation canals to monumental palaces, reflected the same human drive that had once coaxed life from the frozen tundra: adaptation, planning, and endurance. Meanwhile, across the Mediterranean, Rome was quietly learning its own lessons of empire. From its humble beginnings as a collection of villages, it became a city-state capable of astounding feats of engineering, warfare, and diplomacy. Unlike Persia, Rome thrived on integration of conquered peoples into its own system, turning enemies into allies, soldiers into citizens, and cultures into a cohesive whole. The Roman legions, disciplined and relentless, mirrored the survival instincts of humans against nature: precision, coordination, and flexibility in the face of uncertainty. Each conquest, each road built, each law codified was a thread in a tapestry stretching from the first settlements in Mesopotamia to the farthest reaches of the Mediterranean. But these empires were not static. They were living systems, constantly reacting to the pressures of environment, rebellion, and ambition. Droughts in Mesopotamia threatened Persian food supplies. Political intrigue and assassination threatened the throne. In Rome, overexpansion and internal strife became recurring crises. Both civilizations illustrate a truth that resonates through human history. No matter how advanced, humans remain vulnerable to the forces that shaped them: nature, society, and the relentless passage of time. Even culture became a tool of survival and influence. Persian art and architecture communicated power and stability, while Rome's public buildings, forums, and monuments projected civic unity and grandeur. Religion and philosophy were not just spiritual endeavors. They were strategies for cohesion, identity, and control. Zoroastrianism in Persia emphasized moral order and cosmic balance, reinforcing the authority of kings. In Rome, civic religion, law, and philosophy reinforced loyalty to the state, even as the empire absorbed countless peoples and traditions. Here, the echoes of human adaptation are unmistakable. Just as survival once depended on knowledge of seasons, weather, and hunting patterns, now survival on a societal level depended on knowledge of governance, law, and cultural cohesion. And yet, beneath the surface of grandeur, fragility always lingered. Persia would eventually fall to Alexander the Great, a conqueror whose campaigns reshaped the political and cultural landscape of the known world. Rome, after centuries of expansion, would eventually fracture under the weight of its own success, facing invasions, civil wars, and economic strain. Each rise and fall was a testament to the delicate balance between ambition and limitation, growth and overreach. The story of empires is, at its core, a story of humans confronting forces greater than themselves, forces of nature, of logistics, of human ambition, and of history itself. But the tale doesn't stop there. Persia and Rome were not isolated chapters. They set the stage for civilizations yet to come. The administrative brilliance of Persia would influence the governance of later Islamic caliphates. Roman law, infrastructure, and military organization would shape European societies for centuries. The patterns of adaptation, integration, and survival established in these empires became the blueprint for human civilization moving forward, proving that the instincts honed during the Ice Age, resilience, ingenuity, and cooperation, were not lost but amplified across millennia. And this brings us to an intriguing thought. History is not merely a sequence of events. It is an unfolding experiment in human adaptation. Each empire, each civilization, is a response to challenges inherited from both nature and predecessors. Persia, Rome, and the countless societies that followed were not simply players on a stage. They were participants in a vast, continuous experiment, testing how far human ingenuity could stretch in shaping the world. As we turn the page to the next era, the stage is set for even greater transformations: the spread of ideas, religion, and technology across continents, the rise and fall of new empires, and the persistent influence of climate, geography, and human ambition. From the Ice Age survival strategies to the grandeur of empires, the thread is unbroken. And yet, the story is far from finished. Humanity, it seems, has always been on the move, adaptable, inventive, and endlessly striving as the dust settled on the ruins of fallen empires. The echoes of Persia and Rome continued to shape the world. The administrative brilliance of the Achaemenids, the road networks, the systems of governance, and the cultural sophistication endured long after Alexander's conquests had reshaped the landscape. These elements would soon find themselves woven into a new tapestry. The rise of the Islamic caliphates in the 7th century, Arabia, a land of deserts, mountains, and trade routes, produced a unifying force that would alter the course of history. The Prophet Muhammad emerged, not just as a spiritual leader, but as a political and social innovator. His teachings created cohesion among previously warring tribes, much like Cyrus had unified disparate peoples centuries earlier. The Arabian Peninsula became a crucible where spiritual ideology and pragmatic governance merged, producing a state capable of rapid expansion. The conquests that followed were swift and transformative. Within decades, Arab armies moved into the territories once ruled by Byzantium and Persia. The Sasanian Empire, the last great Persian dynasty, fell to the advancing caliphate. But rather than erasing the culture and administration of the lands they conquered, the Arabs absorbed it. Persian administrators, scholars, and engineers became indispensable in the new Islamic states. The Persian system of taxation, provincial governance, and record-keeping was adapted into the caliphate, proving once again that human survival and success rely not just on conquest, but on integration and adaptation. Baghdad, founded in the 8th century under the Abbasid Caliphate, became the crown jewel of this fusion. It was a city of unparalleled ambition, designed as a hub of administration, trade, and knowledge. Scholars from Persia, India, Greece, and beyond flocked to its libraries and academies. Mathematics, astronomy, medicine, and philosophy flourished. Arabic became the lingua franca of science, law, and literature, but carried the imprint of Persian thought, terminology, and organizational principles. Here, the lessons of empire, structure, communication, and cultural blending found their most brilliant expression. Meanwhile, the former Roman territories continued to influence the Islamic world. Byzantine legal traditions, military tactics, and architectural innovations were studied and sometimes adopted. In essence, the Islamic caliphates became a living synthesis. Persian organization, Arab ideology, and Greco-Roman intellect combined to produce one of the most dynamic civilizations the world had ever seen. Yet the story was not just about politics and culture. It was about people navigating a world of uncertainty. Merchants, scholars, soldiers, and ordinary citizens all became part of a vast network spanning continents. Trade routes carried silk, spices, ideas, and inventions across deserts and seas. Knowledge of agriculture, medicine, and astronomy spread from Persia to Spain, from North Africa to India. Humanity's innate drive to survive, adapt, and innovate, the same instincts that guided hunters across Ice Age plains, now propelled societies on a global scale. Conflict and ambition still shape this world. The caliphates faced internal strife, succession disputes, and regional revolts. Yet, every challenge brought innovation, new administrative reforms, military strategies, and cultural achievements. And through it all, the Persian legacy remained alive, quietly guiding the structures, sciences, and philosophies that allowed the caliphates to flourish. That it's remarkable how the story of empires is always interconnected. Persia's rise, Rome's expansion, and the Islamic conquests are chapters of a single human narrative, a testament to adaptability, vision, and the relentless pursuit of order and progress. The thread of history stretches from the frozen steppes of prehistoric humans to the thriving metropolises of the Islamic Golden Age, each generation learning, borrowing, and building upon the past. And yet, even as the Abbasids reached their zenith, the seeds of change were already sown. Far to the west, Europe was emerging from its own period of fragmentation. In the east, the The steppe nomads watched, mobile and unpredictable, ready to reshape borders and cultures. The world was entering a new era of cross-cultural encounters, trade, and conflict, setting the stage for the next grand chapter of human history. As the Abbasid Caliphate reached its height, the world seemed to vibrate with possibility. Baghdad, carefully planned in a circular design around the caliph's palace, was more than a city. It was the heartbeat of an entire civilization. Markets thrummed with merchants from India, Africa, Persia, and Byzantium, bringing spices, textiles, precious metals, and exotic animals. The air smelled of incense and parchment, a heady mix of commerce, scholarship, and ambition. The caliphs understood that power was not maintained by force alone. Knowledge became the currency of influence. Baghdad's House of Wisdom, founded under Caliph Harun al-Rashid and reaching its peak under al-Mamun, attracted the brightest minds. Scholars translated Greek philosophical texts, Persian scientific treatises, and Indian mathematical works into Arabic, preserving and expanding upon the wisdom of previous civilizations. The ideas of Aristotle, Plato, Euclid, and Ptolemy traveled from scroll to scroll, blending seamlessly with Persian advances in medicine, astronomy, and governance. Mathematics flourished. Algebra, introduced by the Persian mathematician Al-Khwarizmi, reshaped calculation, trade, and engineering. Astronomy guided navigation and agriculture. Medicine, informed by the works of Hippocrates, Galen, and Persian pioneers like Rhazes, saved countless lives and built a foundation for modern science. Every discovery, every insight carried the fingerprints of centuries of cultural exchange. Trade routes extended across continents, creating a network unmatched in history. The Silk Road linked Baghdad to Chang'an in China. Ships crossed the Indian Ocean carrying pepper, gemstones, and ideas. Caravans moved steadily through the deserts of Arabia, Persia, and North Africa. Through these channels, cultures collided, merged, and influenced one another. Cities like Cordoba, Cairo, and Samarkand would become distant echoes of Baghdad's brilliance, drawing upon the same currents of knowledge and commerce. Yet, even in the midst of prosperity, tension simmered. The Abbasids relied heavily on Persian bureaucrats, Turkish soldiers, and Arab elites, each with competing interests. Regional governors gained power, sometimes challenging the caliph himself. The world was vast, and maintaining unity required constant negotiation, strategy, and occasional force. These challenges, however, were also opportunities, sparking reforms in taxation, military organization, and legal systems that would outlast the dynasty itself. Cultural life mirrored this dynamism. Poetry, music, and art thrived. Persian literary traditions, especially the epic and lyrical forms, influenced Arabic works, creating masterpieces that celebrated heroism, love, and human aspiration. Architecture combined Byzantine, Persian, and Arab elements. Domes, minarets, mosaics, and gardens created spaces that were both functional and breathtakingly beautiful. People lived not just for survival, but for meaning, beauty, and legacy. This era demonstrates a key pattern in history. When civilizations embrace knowledge, exchange, and cultural fusion, they achieve heights that single empires rarely reach. The Abbasid Golden Age was more than political power. It was the triumph of human ingenuity, collaboration, and adaptability. The same lessons from Persia and Rome, organization, integration, and learning from predecessors, were now elevated to a scale that could shape continents. Yet the world beyond Baghdad continued to shift. Nomadic tribes in Central Asia, ever moving and ever hungry for opportunity, began pressing on the borders. European powers slowly emerged from their own fragmentation. Internal divisions within the caliphate hinted at future challenges. Even as scholars debated, merchants traded, and poets sang, the currents of history were inexorably moving toward transformation. From the ashes of older empires to the thriving streets of Baghdad, one truth remained constant. Human history is a river, carrying knowledge, ambition, and culture across generations. Every conquest, every trade journey, every scholarly pursuit is a link in this chain. And as the Abbasids demonstrated, when a civilization taps into the combined wisdom of its past, it can create a legacy that resonates for centuries. The brilliance of the Abbasid Golden Age could not last forever. By the 10th century, cracks began to appear in the empire's vast facade. Baghdad, once a symbol of centralized power and intellectual dominance, became a city of competing interests. Regional governors, initially loyal, grew increasingly autonomous. Persian administrators, Turkish soldiers, Arab elites. Each faction pursued its own agendas, often at odds with the caliph's vision. The empire was too large to govern from a single center, and the very diversity that had fueled its greatness now created friction at the fringes. New powers were rising. In North Africa, the Fatimids declared independence, establishing their own caliphate with a rival claim to leadership. In the east, Persian and Central Asian dynasties, Samanids, Buyids, and later the Seljuks, exerted control over territories that once answered directly to Baghdad. Trade continued, but political unity fractured. The silk threads of the empire were now tugged in multiple directions, threatening to unravel the tapestry that had taken centuries to weave. Even within Baghdad, tension simmered. Turkish military leaders, initially employed as loyal protectors of the caliph, began to dominate court politics. They installed and removed caliphs at will, effectively reducing the once mighty Abbasids to figureheads. The House of Wisdom continued its scholarly pursuits, but the political instability made long-term planning difficult. Scholars, merchants, and artists were caught between the allure of opportunity and the dangers of a volatile court. Despite the decline, the cultural and scientific legacy of the Abbasids could not be erased. Knowledge traveled along the same routes that had brought wealth and ideas to Baghdad. In Persia, India, and Egypt, centers of learning absorbed and expanded upon the Abbasid discoveries. European scholars, centuries later, would benefit indirectly through translations of Arabic texts preserved and elaborated upon during this era. Mathematics, astronomy, medicine, philosophy. These fields carried the imprint of Baghdad's brilliance far beyond its political collapse. This fragmentation also set the stage for the rise of new empires. The Seljuks in the east would centralize authority again, using both military strength and administrative innovation. In the west, Cairo became a hub under the Fatimids, blending culture and commerce in ways reminiscent of Baghdad's peak. The Ottoman Empire, centuries later, would inherit the legacy of Abbasid governance, culture, and knowledge, proving that even when an empire falls, its influence can endure in unexpected ways. The story of the Abbasids demonstrates a recurring pattern in history. Centralized power and innovation can create golden ages, but sustainability requires balance, adaptability, and resilience against internal and external pressures. Their legacy reminds us that civilization is not solely about conquest or territory. It is about knowledge, trade, culture, and the ability to inspire generations beyond one ruler's reign. In this context, the rise and fall of the Abbasids can be connected to other great empires in history. Just as Rome fragmented under internal and external pressures, the Abbasids experienced a similar trajectory. Initial expansion and consolidation, a period of unparalleled achievement, followed by fragmentation and decentralization. This rhythm, growth, peak, decline, transformation, becomes a lens to understand human history across centuries. As the empire's political grip loosened, new figures and states would emerge, shaping the medieval world in profound ways. Crusades from the west, Mongol invasions from the east, and the eventual rise of the Ottomans would all interact with the remnants of Abbasid influence. Baghdad scholars and merchants had planted seeds that would bear fruit long after the caliphate's political power waned, ensuring that the spirit of inquiry and ambition lived on. By the mid-13th century, the Abbasid Caliphate had long been a shadow of its former glory. Political power had become fragmented, the caliphs mere figureheads under the influence of military leaders and regional dynasties. Yet Baghdad remained a symbol, an intellectual and cultural heart of the Islamic world, a city whose libraries, madrasas, and bustling markets still echoed with the legacy of centuries of innovation. It was a city where knowledge, art, and commerce intersected in ways unmatched anywhere else. But the world around Baghdad was changing violently. From the steppes of Central Asia, the Mongols under Hulagu Khan advanced with unprecedented speed and brutality. Hulagu, a grandson of Genghis Khan, had been tasked with subduing the Islamic world east of the Euphrates. His army, disciplined, vast, and merciless, moved like a storm, leaving no chance for negotiation. The Abbasids, weakened by decades of internal decay, had little hope of mounting a meaningful defense. In 1258, Hulagu's forces arrived at Baghdad. The siege was swift and devastating. Despite the city's thick walls and fortifications, Mongol military engineering and sheer numbers overwhelmed the defenders. Streets ran with chaos as soldiers, fleeing citizens, and desperate caliphal guards clashed in a desperate struggle. Hulagu's forces breached the city, and Baghdad, once a beacon of learning and prosperity, was subjected to massacre and fire. Libraries, including the fabled House of Wisdom, were destroyed. Scholars were killed, texts burned, or carried off to distant lands. Some accounts suggest that the waters of the Tigris ran black from ink and red from blood, a grim symbol of knowledge and life extinguished in one catastrophic moment. The Caliph, Al-Mustasim, was executed, ending the Abbasid dynasty's rule in Baghdad and leaving a void in the political and intellectual leadership of the region. Yet, even in destruction, the spirit of the Abbasid legacy endured. Surviving scholars fled to Cairo, Damascus, and other cities, carrying with them manuscripts and knowledge that would inspire generations to come. The Mongols, after their conquest, eventually converted to Islam in later decades, absorbing aspects of Persian and Arab culture, which had flourished under the Abbasids. This cultural continuity ensured that while the caliphate as a political entity had fallen, its intellectual and artistic influence survived. The fall of Baghdad serves as a stark reminder of the fragility of even the greatest civilizations. It illustrates how internal weakness, political fragmentation, and external pressures can converge to bring down a once mighty empire. Yet history also shows resilience. Ideas, art, and culture often outlast empires themselves, carried forward by people, trade, and scholarship. From this point, the story naturally leads to the rise of new powers in the Islamic world: Cairo under the Mamluks, Persia under the Ilkhanids, and eventually the Ottomans, who would inherit, protect, and transform the legacy of the Abbasids. The Mongol invasions, while catastrophic, became part of the intricate tapestry of Middle Eastern history, demonstrating how destruction and renewal often walk hand in hand. The smoke from Baghdad's burning skyline had barely cleared when the ripples of its destruction began to shape the political, cultural, and intellectual map of the Middle East. Though the Abbasid Caliphate in Baghdad had fallen in 1258, the essence of what it had built, its scholarship, artistic vision, and intricate bureaucratic systems, refused to vanish completely. Knowledge, like a river, always finds a new path, and the survivors of Baghdad's calamity carried this current of civilization to new centers, ensuring that the Abbasid legacy would influence generations far beyond its political lifespan. Many scholars and administrators fled west to Cairo, where the Mamluk Sultanate had begun consolidating power. The Mamluks, former slave soldiers who had seized the reins of Egypt and Syria, recognized the value of Baghdad's intellectual treasure. Manuscripts salvaged from the ruins, ranging from advanced mathematics and astronomy to medicine, philosophy, and poetry, arrived in Cairo, enriching the libraries of Al-Azhar and other centers of learning. The migration of knowledge sparked a renaissance of scholarship in Egypt and the Levant, blending Abbasid sophistication with local and emerging Islamic traditions. Meanwhile, in Persia, under the Ilkhanids, the Mongol rulers who eventually embraced Islam, Baghdad's destruction left an indelible mark. Persian bureaucrats and artisans, long influenced by Abbasid models of administration and art, helped the Ilkhanids create an empire that combined Mongol military discipline with Persian cultural sophistication. Cities like Tabriz, Shiraz, and Isfahan flourished, becoming hubs of poetry, miniature painting, architecture, and scientific inquiry. The synthesis of Persian traditions and Abbasid intellectual heritage produced a flowering of culture that would endure for centuries. Even further afield, Baghdad's legacy subtly reached Europe. During the Crusades, European merchants, scholars, and diplomats had encountered Islamic science, philosophy, and technology. After the Mongol invasions, refugees carrying manuscripts, instruments, and ideas traveled along trade routes through the Levant, Anatolia, and even into Italy. Translations of these texts, particularly in mathematics, medicine, and astronomy, helped ignite the European Renaissance. Figures like Fibonacci, who introduced Arabic numerals to Europe, were part of this larger wave of knowledge transfer. Baghdad, in its destruction, paradoxically became a conduit through which the wisdom of the Islamic world enriched a new continent. Culturally, the aesthetic achievements of the Abbasids, calligraphy, architecture, poetry, and decorative arts, continued to shape the Islamic world. The intricate arabesque designs seen in Mamluk mosques and Ottoman palaces can trace their roots back to Abbasid creativity. The storytelling traditions cultivated in Baghdad, from epic poetry to the tales collected in 1001 Nights, traveled across the Middle East and North Africa, preserving not just literary forms, but the very spirit of intellectual curiosity and imagination that had defined the caliphate. Politically, the notion of the caliphate survived as a symbolic institution, even if its temporal power had waned. Cairo became the new seat of the Abbasid caliph in exile, a figurehead to legitimize Mamluk authority. This continuity preserved the idea of a unified Islamic leadership while allowing local powers to rise. It illustrated a critical lesson. Empires fall, but the symbols, ideas, and structures they leave behind often endure, shaping the trajectory of civilizations for centuries. The fall of Baghdad also served as a cautionary tale. Leaders and rulers across the region learned that internal division, complacency, and underestimation of external threats could bring even the mightiest empires to ruin. Yet, it also demonstrated resilience. Human ingenuity, scholarship, and culture could survive even the harshest cataclysm, finding new homes and evolving in response to changing circumstances. Baghdad's destruction was not the end of the story. It was a turning point, a transformation from one phase of Islamic civilization to another, and a bridge connecting the golden age of the Abbasids to the vibrant cultural and political landscapes of the Mamluks, the Ottomans, and beyond. In this sense, the history of Baghdad is more than the tale of a city. It is a story of human achievement, loss, and the enduring power of knowledge. It reminds us that while empires may crumble under the weight of conquest and mismanagement, the ideas and culture they nurture can survive, travel, and even thrive in new contexts, influencing people and civilizations far into the future. As the smoke of Baghdad's destruction faded into memory, the Middle East entered a period of fragmentation, with former Abbasid and Mongol territories divided among competing powers. Yet, from the chaos emerged a new force that would redefine the Islamic world for centuries: the Ottomans. In the early 14th century, in the rugged lands of northwestern Anatolia, a small principality under the leadership of Osman I began consolidating power. The Ottomans were heirs not only to the lands, but also to the knowledge, administration, and cultural practices cultivated by the Abbasids, Seljuks, and later the Ilkhanids. The Ottomans inherited more than just territory. They inherited a blueprint for governance. Persian bureaucratic models, which had already permeated the Abbasid system, informed the Ottoman approach to administration. Viziers, court scribes, and tax officials relied on centuries-old methods of record-keeping, land management, and fiscal organization. The sophistication of Baghdad's former civil service, its combination of central authority with provincial autonomy, was mirrored in Ottoman provincial governance, enabling a relatively small ruling elite to control vast and diverse territories efficiently. Culturally, the Ottomans absorbed the artistic and intellectual currents flowing from Baghdad and Persia. The architectural splendor of early Ottoman mosques, palaces, and caravanserais reflected influences from Abbasid and Seljuk designs, while calligraphy and manuscript illumination maintained stylistic continuity with earlier Islamic traditions. Scholars and artisans who had fled Mongol invasions or Mamluk consolidation found refuge in Ottoman lands, bringing with them scientific knowledge, medical texts, astronomical instruments, and literary treasures. This influx fueled Istanbul's transformation into a cosmopolitan hub, where East and West, old empires and new, converged in a vibrant cultural milieu. Militarily, the Ottomans learned from the successes and failures of their predecessors. They understood the importance of disciplined, well-organized armies, a lesson taken from Mongol cavalry tactics, and integrated it with local knowledge of fortifications, siegecraft, and naval warfare. By the mid-15th century, under Sultan Mehmed II, the Ottomans executed the culmination of centuries of strategic learning, the conquest of Constantinople in 1453. This event not only marked the end of the Byzantine Empire, but symbolically positioned the Ottomans as the inheritors of both the Roman legacy in the West and the Islamic legacy in the East. The Ottoman Empire also became a custodian of Islamic intellectual heritage. Manuscripts salvaged from Baghdad, Cairo, and other centers were meticulously copied, studied, and preserved in Istanbul's libraries. Institutions of learning, such as madrasas, flourished alongside emerging artistic and literary movements. The sultans themselves were often patrons of scholars, poets, and architects, reinforcing a continuity of culture that stretched back to the golden age of Baghdad. Trade and diplomacy further extended the Ottoman reach. By controlling key routes between Europe, Asia, and Africa, the Ottomans became conduits for the movement of ideas, goods, and technology. European travelers, merchants, and diplomats encountered a civilization that had inherited centuries of Abbasid scholarship, Mamluk refinement, and Persian administration. Innovations in science, engineering, and literature continued to flow westward, shaping the intellectual landscape of Renaissance Europe even as Ottoman power grew in the East. Yet for all their success, the Ottomans also faced challenges reminiscent of Baghdad's decline: internal dissent, ambitious provincial governors, and external threats from powerful neighbors. The lessons of history, how empires can rise swiftly and fall suddenly, were not lost on the Ottoman rulers. They studied the archives of the Abbasids, the chronicles of Mongol rulers, and the accounts of Mamluk sultans to understand the fragility of power and the importance of cultural and intellectual resilience. By the late 16th century, the Ottoman Empire had become a vast, multi-ethnic, and multilingual empire spanning 3 continents. Its administrative, cultural, and military systems were a living mosaic of the legacies it had absorbed: Abbasid scholarship, Persian bureaucracy, Mamluk artistry, and Anatolian martial tradition. In essence, the Ottomans were not starting from scratch. They were building upon the accumulated wisdom of centuries, proving that even after catastrophic destruction, the threads of knowledge, culture, and governance could be woven into something enduring, magnificent, and world-changing. By the late 16th and early 17th centuries, the Ottoman Empire had solidified its position as one of the most formidable powers in the world. The empire stretched from the gates of Vienna in the west to the Persian frontiers in the east, encompassing Anatolia, the Balkans, the Levant, and North Africa. Istanbul, once Constantinople, had become the vibrant heart of a transcontinental empire, a city where traders from Venice, Cairo, and Samarkand mingled, where scholars debated philosophy, mathematics, and astronomy, and where mosques and palaces rose in architectural harmony reminiscent of Baghdad's golden age. The Ottoman success was deeply tied to their ability to integrate the legacies of past civilizations. Abbasid administrative practices ensured an efficient bureaucracy that could govern diverse peoples. Persian artistry and scholarship enriched Ottoman culture, while the lessons of Mongol military discipline informed the structure of elite units like the Janissaries. Each conquest, from Belgrade to Cairo, was both a military achievement and a cultural acquisition, absorbing knowledge, art, and science into the empire's ever-growing mosaic. Yet, this apex brought the empire into direct confrontation with Europe. As Ottoman naval power expanded into the Mediterranean, the empire faced Venetian merchants, Spanish galleons, and later Dutch and English trading companies. Trade routes became arenas of diplomacy and conflict, and the Ottomans' control over key cities such as Aleppo, Alexandria, and Constantinople allowed them to dominate commerce between East and West. European travelers described the empire as simultaneously ancient and modern. Streets thronged with merchants and artisans, libraries stocked with manuscripts salvaged from Baghdad and Cairo, and scholars who continued the traditions of mathematics, medicine, and astronomy. Cultural exchange was not one-sided. Ottoman scholars translated European works in navigation, astronomy, and military engineering, while European diplomats and envoys returned home with knowledge of Ottoman administration, art, and science. This flow of information reshaped both continents, demonstrating that empires built on inherited knowledge could influence regions far beyond their borders. The military, too, remained a critical tool of Ottoman dominance. The Janissaries, trained from a young age in both discipline and combat, embodied lessons learned from centuries of warfare. Siegecraft perfected over generations allowed the Ottomans to conquer Constantinople and later defend strategic fortresses across Europe and the Middle East. Cavalry and artillery, blended with knowledge from Persian, Mamluk, and European sources, made Ottoman armies both adaptive and formidable. But the empire was not immune to the forces of decline that had toppled earlier powers. By the 17th century, administrative corruption, provincial autonomy, and the challenge of maintaining such a sprawling territory began to strain the central government. Rebellions flared in distant provinces. European powers increasingly challenged Ottoman dominance in the Mediterranean, and technological advancements in Europe threatened to outpace Ottoman military innovations. Despite these challenges, the Ottomans' ability to draw upon centuries of accumulated wisdom allowed the empire to endure. Cultural institutions thrived. Mosques and palaces continued to be constructed with intricate artistry inspired by Persia and the Abbasids, and trade and diplomacy maintained the empire's influence across continents. Ottoman leaders understood that survival depended not only on military might, but also on the preservation and cultivation of knowledge, culture, and economic networks. That by the end of the 17th century, the Ottoman Empire had become a living testament to the resilience of civilizations. From the ruins of Baghdad to the palaces of Istanbul, from the battlefields of Anatolia to the bustling markets of Cairo, the legacy of past empires endured in governance, culture, and intellect. The empire's story was one of continuity amidst change, showing that even after centuries of upheaval, the threads of history could be woven into an enduring and dynamic civilization. As the 18th and 19th centuries unfolded, the Ottoman Empire faced a world that was changing faster than ever before. Across Europe, the Industrial Revolution reshaped economies, societies, and armies, while the rise of nation-states challenged the old dynastic and imperial order. The Ottoman Empire, vast and diverse, struggled to adapt. Its centuries-old administrative systems, which had once efficiently managed Anatolia, the Balkans, and the Middle East, now contended with modern bureaucracies, nationalist movements, and foreign pressures from rising European powers such as Britain, France, and Russia. Wars, internal rebellions, and territorial losses became increasingly frequent. The empire that had once extended from Vienna to Baghdad and from Algeria to Yemen gradually shrank. Cities that were once central to Ottoman commerce, like Aleppo, Alexandria, and Thessaloniki, felt the encroaching influence of European trade companies, modern navies, and new economic policies that undermined Ottoman control. Yet, even as borders contracted, the cultural and intellectual imprint of the empire remained profound. Ottoman architecture, calligraphy, literature, and scholarship continued to inspire, bridging the heritage of the Abbasids, Persians, and earlier civilizations with the modern world. During this period, reforms known as the Tanzimat attempted to modernize the military, legal system, and economy. New schools were built, printing presses spread knowledge, and attempts were made to codify laws in ways that could match European standards. While these reforms were uneven and often met with resistance, they reflected a central truth. The Ottomans, even in decline, understood that knowledge and adaptation were essential to survival. The empire's leaders drew on centuries of accumulated experience, from Abbasid administration to Persian scholarship, trying to navigate an era dominated by industrialized powers and global empires. Ultimately, the First World War proved to be the final test. The empire, weakened but resilient, entered the conflict alongside the Central Powers, seeking to protect its territories and assert its relevance. The war accelerated existing fractures, and by 1922, the Sultanate was abolished. Yet the story of the Ottoman Empire did not vanish with its political end. Its cities, monuments, and cultural achievements remained living legacies. Istanbul retained its status as a bridge between continents. The mosques, palaces, and libraries preserved knowledge, and the memories of centuries of administration, warfare, and diplomacy influenced the nations that emerged from Ottoman lands. Looking back across the centuries, from the Abbasid scholars who shaped administration and science, to the Persian artists and thinkers who enriched culture, to the Ottomans who blended heritage with ambition, we see a continuous thread of civilization. It is a story of adaptation, of learning from the past, and of the enduring power of knowledge and culture to outlast empires themselves. Though borders shifted and rulers changed, the legacies of governance, scholarship, art, and resilience endure. The empire may have faded, but the civilization it carried forward continues to shape our world today. This is the story of empires rising and falling, yet leaving behind threads of wisdom, culture, and human achievement. A reminder that the past is never truly gone, but lives on in the world we inherit.